I'm speaking here now specifically to those of you that are going to be headed to pre-calculus and calculus. There is a skill that your pre-calculus and calculus teachers are going to want you to have, and that is the ability to quickly find exact values of trig functions without a calculator. On the AP calculus test, for example, you are expected to be able to evaluate, say, the cosine of 300 degrees without having a calculator available and to be able to give a numerical answer. Now, quite frankly, for those not going to pre-calculus, you've got better things to do with your time. So I'm speaking now just to those of you heading to pre-calculus and calculus. Here's the deal. Cosine of 300 and angles like this. When you have a reference angle that's either 30 degrees, 45 degrees, or 60, then you are expected to be able to give those trig ratios very quickly. Some people prefer just to memorize the unit circle, and depending what you do in pre-calculus next year, you may choose to do that. I don't like to do that. I'm not a good memorizer. I instead use this method to evaluate these trig functions relatively quickly without having to have everything memorized. Here we go. My strategy is this. First thing to do, take a look at your angle. Right now, I don't care whether it's sine, cosine, or tangent. All I care is that it's 300 degrees. You do need to be able to very quickly place that 300 degrees. So you need to know that this is 0, 90, 180, 270, and then back to 360 again. So 300, that's going to be between 270 and 360. So this angle is right in here. That needs to be a quick thing. Next, determine your reference angle. Well, in this case, it's this missing part. So if I've gone 300 degrees to get to that full 2 revolutions, I need an additional 60 degrees. So place your angle, determine the reference. That whole thing has got to take just a few seconds. Once that's done, set up a special triangle. So I'm going to take this here and make a triangle out of it, just off to the side. And you can do this in your head eventually. But set up a triangle. It's got 60 degrees here, 30 degrees there. This is now my special triangle. And by special triangle, I mean a 45-45-90 or a 30-60-90. This one's 30-60-90. So this is the part of the process that I do have memorized. You've got to know these ratios. In a 30-60-90, and actually tell you what, I'm going to redraw my triangle just a little bit better because the 60-degree angle should be the bigger angle in the triangle, right? Because 60 degrees is twice as big as 30 degrees. So all I've done is I've redrawn this triangle to be a little bit more accurate, just to make sure I put my numbers in the right spot. The hypotenuse has a length of 2. The short side, that's going to be across from a 30-degree angle, is exactly half of that. And then the other one, the one that's left, is square root of 3. This is what I have memorized, the ratios in that 30-60-90 triangle. So we put our angle, found the reference, set up the triangle. Now it's just a matter of SOHCAHTOA. Cosine is adjacent over hypotenuse. That's 1 over 2. Look how simple this can be. and now I'm essentially done. The final thing to check, though. Now, notice we have not taken into account whether I want things to be positive or negative. That's the last step. Several ways you can do this. Frankly, the way that I like to do it is with this mnemonic. It's A, S, T, C. You go around the circle and you just say, all students take calculus. ASTC, all students take calculus. This tells you what's positive in that quadrant. So in quadrant 1, sine, cosine, and tangent, all of them are positive. In quadrant 2, it's only the sines that are positive. In quadrant 3, it's only the tangents. And in quadrant 4, it's only the cosines. All students take calculus. ASTC tells you what's positive. So I'm in quadrant 4 because that's where I placed my angle. I got a cosine, so I want a positive 1/2. There it is. So just a quick check. It's not that I don't think you trust me, but I'm going to do a cosine of 300 degrees. And I always keep my calculator in radian. So whenever I want to do a trig function with degrees, I just do second apps to find that degree symbol. And sure enough, it's going to give us a 1/2. Okay, let's do a recap here because we clearly spent more than 15 seconds this time. So you place your angle, determine your reference, set up a triangle, then use SOHCAHTOA, and check your positives and negatives. You'll notice there's a practice sheet for this section. It's got lots and lots of these on there. The way you get fast at this is you do this lots and lots and lots of times. That's why there are so many on there. Okay, let's go again. So tangent of 690. Step one, place your angle. So 690, that's a full 360. So I'm back where I started. And then I'm just going to take the 690 minus 360 for that full spin around. Okay, so it's another 330. So 0, 90, 270, 330 is going to be over here, meaning I've got 30 degrees left to complete that full rotation. Now, another way I could have gotten there more quickly is to say, well, 2 full rotations is 720 degrees. I need 30 more degrees to make that happen, so there's my 30-degree reference. All right, now set up my special triangle, try and draw it a little bit accurately. So there's my 30, there's my 60. So 2, 1, and square root of 3. Tangent, opposite over adjacent. I'm in quadrant 4, and so only cosine is positive. That means the tangent is negative. There you go. Now, just so you know, this is not how your answer will show up on the answer key. I mean, to be honest, it's going to depend on your teacher. I don't care if you leave it like this. But the answer key is going to have it written this way. It's the same thing. We call that rationalizing the denominator. So let's just do a quick check here. The tangent of 690 degrees. Okay, we think that it is negative 1 divided by square root of 3. Come on, calculator. Divided by square root of 3. Yep, sure enough, there we go. But the way your answer key has it is negative square root of 3 divided by 3, and you're going to see it's the same number. So why would you take an additional step to write it another way? It's a custom to have whole number denominators and not square roots in your denominators. It's a custom I don't care about. So like I said, as far as I'm concerned, go ahead and stop here. But your answer key and maybe your teacher next year is going to want you to get here. It's a very easy fix to do. When you end up with a square root in the denominator, like we did, then all you do is you multiply by that same square root, top and bottom. Because root 3 over root 3 is really equivalent to a 1, so you're not changing the size of the number. We're only changing how it looks. And then across the top, 1 times square root of 3 is square root of 3. On the bottom, root 3 times root 3 is square root of 9, which is whole number 3. So this is also okay. This is how it will show up in the answer key. Okay, let's go again. The steps. Now, if you haven't already done a pause and tried it yourself, please do so. Counting in radian, here's how I like to think about it. We're counting by pi over 3s. That means that 3 of them is halfway around, and then I've got 1 more. So halfway around and 1 more pi over 3. There we go. That's my reference angle. Now, pi over 3, I need you to be able to quickly know is the same as 60 degrees. So we're looking at a 30, 60, 90 triangle in quadrant 3. Label my sides, 2, 1, and root 3. Tangent, opposite over adjacent. So that's square root of 3 over 1, which is just square root of 3. I'm in quadrant 3, ASTC, tangent is positive. So there it is, all done. Let's go again. Now, here's what will happen. I'll uncover this one. I really do want you to pause the video and try to do it as quickly as you can. And then unpause when you're ready to check. Okay, cosine negative 3 pi. So it's measuring in radian. Negative 1, 2, 3 pi puts us right here. No special triangle this time because you are right on this ordered pair in the unit circle. You need to know that the cosine is the x-coordinate. You're all done. So if they fall right on one of the axes, it's a fairly straightforward process. Okay, a couple more here. Well, a trio more. Cosine negative 210. Again, if you haven't already done a pause and try it yourself, please do. Okay, so that's negative 180 and then another negative 30. So it's a 30-degree reference in quadrant 2. So in my triangle, that's my 30. Then this is 2, 1, and square root of 3. Cosine, adjacent over hypotenuse, so square root of 3 over 2. And because I'm in quadrant 2, only the sign is positive. I want the negative root 3 over 2. And every once in a while, especially as you're learning, it's not a bad idea to give these a calculator check as well. So negative 210 degrees is this number, and I think that it should be negative square root of 3 divided by 2. Sure enough, they're the same, so we've done good. Next up, sine negative 7 pi over 4. All right. So counting by pi over 4s, that means 4 of them is a half turn, and then I need 3 more. So 3/4 of the way around again. That's going to put me right here with a 45-degree reference, a pi over 4 reference in quadrant 1. All right, then, set up my triangle. Now, 45, 45, 90 has side ratios of 1, 1, square root of 2. So the two legs are the same, and then the hypotenuse is square root of 2 times as long. So for the sine, I want opposite over hypotenuse. That's 1 over square root of 2. I'm in quadrant 1, so everything is positive. There you go. You won't see it this way, though, on your answer key. It's going to do that rationalization trick. So multiply by root 2 top and bottom. This is what your, that's a 2. This is what your answer key is going to have. They are the same thing. You pick whichever one you like better. Okay, last one. Try and race. Oh, a little slow. So 17 pi over 6. So there's 6, 12. It would be 18 to get another halfway around again. So I've got 1 short. I'm 1 pi over 6 short, which is 30 degrees. So a 30-degree reference in quadrant 3, that's going to be 1, 2, and square root of 3. The cosine is adjacent over hypotenuse, so root 3 over 2. And in quadrant 3, cosine is negative. There you go. Please, if you have gone this far in the recording, I hope that you are someone who is saying, hey, I've got a pre-calculus class coming up and a calculus class. You will be expected to be able to do this quickly. Please now work through that entire practice sheet. And then once you've done that, hit up Khan Academy, hit up some Quizlets online just for some more of that quick practice, because this does need to be something that comes fast.